Hi there, Miss Barber here. Former U.S. President Barack Obama, referring to a congressional debate over the debt ceiling, remarked, "We can't not pay bills that we've already incurred." In this lesson, titled Equivalent Statements and Variations of Conditional Statements, we learn to recognize and construct logically equivalent statements. For example, the above statement can equivalently be expressed as we must pay bills that we've already incurred. Note, can't not is a double negation which is easily replaced with must. Let's begin with some definitions. Statements that have the same truth values in the final column of their truth tables are said to be equivalent or logically equivalent. This equivalency is denoted by the double-sided arrow. Be sure to memorize this definition, that is, know it by heart. Example, determine which, if any, of the following pairs of conditional statements are equivalent. Part A, P implies Q and Q implies P. To construct the truth table, we begin with two columns, one labeled P, followed by true, true, false, false, and one labeled Q for the second statement, followed by true, false, true, false. Let's look at the definition of the conditional P implies Q. We have the definition memorized, and that would be truth implies truth is true, true implies false is false, false implies true is true, and false implies false is also true. Now let's construct Q implies P. So now we're looking at truth implies truth, that's true. False implies true, that's also true. How about true implies false? That is false. And finally, false implies false is true. The variation of this conditional statement is called a converse. It's important to note that a conditional statement and its converse are not equivalent. Notice that the final columns of the truth values for P implies Q and Q implies P are different. Part B, P implies Q and not P implies not Q. We begin with the standard truth table for two statements P and Q. Following P in the rows, we have true, true, false, false. Following Q, we have true, false, true, false. Let's begin with the conditional P implies Q. That definition we have memorized. And so in the following rows, the definitions are true, false, true, true. Now let's negate P. That means we want the opposite truth value for what we initially began with P. If we had TT, that's true, true, false, false, then the negation would be false, false, true, true. Let's do this for the negation of Q. If Q was true, false, then the negation would be false, true, true. Let's set up the conditional. Not P implies not Q. False implies false is true. False implies true. That's also true. True implies false. That's false. And true implies true is true. Let's make a cursory observation that P implies Q and not P implies not Q have different truth values. This variation of the conditional statement is called an inverse. Let's observe. A conditional statement and its inverse are not equivalent. Part C. P implies Q and not Q implies not P. We start with a standard truth table. We have two columns for the statements P and Q. Following P, we have the truth values true, true, false, false. Following Q, we have the truth values true, false, true, false. Let's look at the conditional. P implies Q. That definition is true, false, true, true. The only time you get a false in a conditional is if you have truth implying something false. Now let's construct not Q. That means we're going to negate the truth values for Q. We will get false, true, false, true. Let's do that for negating P. The negation of P will give us false, false, true, true. And then finally set up the conditional. Not Q implies not P. We look at false implies false. That's true. True implies false. That is false. False implies true. That's true. True implies true is true. Observe. P implies Q and not Q implies not P. Those columns, the truth values are the same. This variation of the conditional statement is called a contrapositive. Observe. A conditional statement and its contrapositive are logically equivalent. Example, construct or write the contrapositive for each of the following statements. Part A, if I am in Denver, then I am in Colorado. Let's begin by identifying statements. I'll let P be the statement I am in Denver and Q be the statement I am in Colorado. So to express if I am in Denver, then I am in Colorado symbolically, we would have P implies Q. The contrapositive of P implies Q is not Q implies not P. Expressing that in words, we would have if I am not in Colorado, then I am not in Denver. Construct or write the contrapositive for the statement, if the stereo is not playing, then I can hear you. I'll let P be the statement, the stereo is playing, and Q be the statement, I can hear you. Then symbolically, this conditional statement could be expressed as not P implies Q. The contrapositive of P implies Q is not Q implies not P. The contrapositive of not P implies Q, which is our statement, is not Q implies not P. And not P is just P. Negating a negation gives you just the statement. Thus, the contrapositive of this statement, that is not P implies Q, is not Q implies P. Use those symbols to express if the stereo is not playing, then I can here use contrapositive in words. We would have, if I cannot hear you, then the stereo is playing. Part C. Construct or write the contrapositive of the statement. If all students are honest, then supervision during exam is not required. Let's assign letters to each parts of these statements. I'll let P be all students are honest. Then Q would be supervision during exams is required. To express if all students are honest, that would be P implies. Supervision during exam is not required would be not Q. P implies not Q. The contrapositive of P implies Q is not Q implies not P. Let's construct the contrapositive of P implies not Q. The contrapositive of P implies not Q is not Q implies not P, and not Q equals Q. The negation of negation takes us back to the original statement. Thus, the contrapositive of this statement, P implies not Q, is Q implies not P. Use those symbols to write the contrapositive in words. We would have, if supervision during exams is required, then not all students are honest. Part D. Construct the contrapositive for not, and in parentheses, P or Q implies not Q. This time, I'm going to provide you the definition of the contrapositive using completely different letters. The contrapositive of A implies B is not B implies not A. Let's apply that definition to our given statement. Then we would have not Q implies not P or Q. Let's simplify the two negations, and so not Q would just be Q, and that would imply not P or Q. Those negations cancel, and you get P or Q. Example, write the inverse and converse of the statement. If you are in Denton, Texas, then you do not have an ocean view. Let's assign statement letters. So we'll let P be the statement, you are in Denton, Texas, and Q be the statement, you have an ocean view. Now, if your conditional statement is if you are in Denton, Texas, then you do not have an ocean view. Symbolically, we would write that as P implies not Q. The inverse of P implies Q is not P implies not Q. We're going to apply that to P implies not Q. So the inverse of P implies not Q is not P implies not Q. Thus, the inverse of this statement, P implies not Q, is not P implies Q. Let's express that in words. If P is you are in Denton, Texas, then not P would be if you are not in Denton, Texas. And if Q is you have an ocean view. Let's put that together. If you are not in Denton, Texas, then you have an ocean view. Let's do this for the converse. P, you are in Denton, Texas. Q, you do have an ocean view. To write if you are in Denton, Texas, then you do not have an ocean view. Symbolically, that would be P implies not Q. The converse of P implies Q is Q implies P. Just switch the order. Thus, the converse of this statement is not Q implies P. Let's replace those symbols with words. If you do not have an ocean view, then you are in Denton, Texas. Example, for each of the pairs of statements, determine whether they are equivalent and explain. Part A, if I show up to class, then I'll get an A. Statement 1. If I got an A, then I showed up to class. That'll be our statement 2. Let's assign statements some letters. I'll let P be the statement, I show up to class. Then Q will be the statement, I will get an A. So, for the first statement, symbolically, we would write that as P implies Q. Now for the second statement, if I got an A, then I showed up to class. Symbolically, we would write that as Q implies P. The two statements are not equivalent because they are converses of each other, and we have learned that a statement and its converse are not equivalent. Part B. If Baby Shark is the best song of 2019, then I'll eat dirt. If I don't eat dirt, then Baby Shark is not the best song of 2019. Let's assign to those words symbols I'll let P be Baby Shark is the best song of 2019. Q is I'll eat dirt. So for statement 1, where we have if Baby Shark is the best song of 2019, that would be P, right arrow, I'll eat dirt is Q. Symbolically, that would be P implies Q. And for the statement 2, if I don't eat dirt, so that would be not Q, then Baby Shark is not the best song of 2019. That would be not P. So symbolically, not Q implies not P. Those two statements are equivalent as they are contrapositives of each other. A conditional statement and its contrapositive are logically equivalent. C. If I buy a laptop, then I will not buy a desktop. The second statement is, if I don't buy a laptop, then I will buy a desktop. Let's give symbols so we can write this symbolically to the words. I'll let P be the statement, I buy a laptop. Then Q will be my statement, I do not buy a desktop. Notice that this statement, I left the negative in there. Symbolically, for the first statement, that's just P implies Q. For the second statement, if I don't buy a laptop, then I will buy a desktop. Observe that buy a desktop is a negation of I do not buy a desktop. So symbolically, that would be not P implies not Q. These two statements are not equivalent as they are inverses of each other, and we know that a conditional statement and its inverse are not logically equivalent. Example, consider the statement, I maintain a 3.5 GPA or I lose my scholarship. Part A, assign simple statements to P and Q. I'll let P be the statement, I maintain a 3.5 GPA. And I'll let Q be the statement, I lose my scholarship. Then, when I construct the symbolic statement, this will simply be P or Q. Part C, for the following statement, construct the symbolic statement that corresponds to if I don't maintain a 3.5 GPA, then I lose my scholarship. So that would be not P implies Q. If P is I maintain the 3.5 GPA, then I don't maintain the 3.5 GPA would be not P. Construct a truth table for both the compound statement and the conditional statement. Provided here is a truth table with statements for P and Q. Following P are the truth values, true, true, false, false, and following Q are the truth values, true, false, true, false. The compound statement was P or Q. I maintain my 3.5 GPA or I lose my scholarship. The conditional statement was not P implies Q. If I don't maintain my 3.5 GPA, then I lose my scholarship. Let's work on the truth table. For P or Q, that's a disjunction. So true or true is true. True or false, that's true. False or true is also true. And false or false, that is false. Now we need the negation of P, and so we'll negate the truth values for the P where we had true, true, false, false. The negation would be false, false, true, true. Now let's construct the conditional statement, not P implies Q. False implies true. That's true. False implies false. That's also true. True implies true. That's also true. But true implies false. That is false. Part E says make an appropriate conclusion about the two statements. We observed that P or Q and the statement not P implies Q have final columns with matching truth values. That is, those are equivalent. I either maintain my 3.5 GPA or I lose my scholarship. That is logically equivalent to if I don't maintain my 3.5 GPA, then I lose my scholarship. So an appropriate conclusion would be the two statements, P or Q, and not P implies Q, are logically equivalent.